Welcome to Carlton's Math Corner. Today we're going to continue our study on absolute value. At this time, please make sure that you have your math journal, vocab packet, something to write with, and of course a smile on your face, because learning is fun. Our target today is I can solve absolute value equations. So in our last video, we evaluated absolute value expressions. Okay, so it was just one mathematical sentence. Now in this case, we have an equation. So we have one mathematical sentence equal to another one. And so looking at this equation is going to have absolute value symbols within it. My question for you is, what number or numbers could f be to make the left side equal to the right side? So what value could f be to equal, well, when added to 5, could equal 17? So what value or values, could be more than one, could we use to equal 17? And I want you to keep in mind, absolute value means the distance from 0. Okay, so keep that in mind when you're trying to figure that out. Well, I know if I take 12 plus 5 equal to 17, I know this is true even if I have the absolute value symbols, even if these, even if my absolute value symbols are around the 12 and the 5, because 12 plus 5 is 17, and positive 17 is 17 spaces from 0. So I know that my answer would be 17, and so that means the left side is equal to the right side. Is there another number that it could possibly be? Nice job, those of you that said negative 22. You are absolutely correct. Let's try it. What's negative 22 plus 5? Okay, negative 17. But now I want you to put absolute value symbols around it. So what is the absolute value of negative 17? Well, how many spaces is it from 0? How many hops? 17. And so we still get the same answer as the right side of this equation. So there's actually two answers, positive 12 and negative 22. How do we get those answers? Like those of you that maybe got the 12 but did not get the negative 22, how could we get that negative 22? Well, let's look at this problem a different way. What do you notice? Well, I notice that the f plus 5 remained exactly the same, okay? But on the right side, where the 17 is by itself and there's no absolute value symbols around it, I notice that there's a positive version of it and then there's a negative version of it, okay? That's what I notice. And the reason why that is because we need to keep in mind that a positive number and a negative number, both their absolute values turn out to be positive. Okay, so we have to consider both positive and negative. And so when we put the positive and the negative of the 17, look what happens when we solve these equations. So remember, this is a one-step equation, so we just have to get rid of the 5. And we're doing the inverse operation. So instead of plus 5, we're going to subtract 5. So 17 minus 5 is 12. Okay, so f is equal to 12. On this side, since I changed the 17 to a negative 17, because negative 17, the absolute value of that would be 17, and positive 17, the absolute value of that is also 17. That's why we're putting them both down here. So if I get rid of the positive 5 and put minus 5 again, I get negative 17 minus 5, and that's negative 22. And those are the two answers that we came up with. Both of them worked. And we actually showed that we put 12 in and then we put negative 22 in, and we took the absolute value of it and we got 17. Okay, so if I wanted to plot these 2 points on a number line, well, first of all, I would need to write down these, like I need a number line that shows these numbers. And remember, the negatives go to the left, positives go to the right. So if we start down at, let's say, negative 25, and we're going to go up, oops, because I have to get to positive 12, and I only have so many spaces to work with. So if I go up by 10s are probably not, or 5s are probably not going to work it. So let's go up by 10s. Negative 5, and then 0, or not 0, 5, then 15. Well, even just those numbers, I don't have to use all of the dashes. I could keep going, but I counted by 10s, and that works. So now I can plot these numbers. These are the answers for this absolute value. So positive 12, which would be, here's 15, 13, 14, 12, about right there. And then negative 22 would be about right there. Okay, those would be the 2 answers, or 2 solutions for that absolute value. Now, what's different about this one? Yes, those of you that said, well, there's a number on the outside of the absolute value. We did not have that on the last problem. If you look at the last problem, there was no number on the outside of the absolute value on the left side. And so that's what's different here. We have minus 3, and because we have the minus 3, look what happens to it. How did we get the 15? Yes. We got rid of the minus 3 by doing the inverse. So we added 3, we got it over to the other side, so now we have 15. Now this equation looks similar to the one from before. There's one number on the right side, and then our absolute value is on the other side. And so now we can solve this. This is 3b equals 15, but it also is 3b is equal to negative 15. And so once we solve this, it's just a one-step equation. Instead of multiplication, we would divide. 15 divided by 3 is 5. And then over here, negative 15 divided by 3 is negative 5. And we could check these answers. If I take and I put in 5 in for B, so we have 3 times 5 is 15. Absolute value of 15 is still 15, minus 3 is 12. So that works. How about if we change this to a negative 5? 3 times negative 5 is negative 15. Now the absolute value of that is 15. 15 minus 3 is still 12. So yay, they both work. Check. So I could put a check mark on both of these and say, yep, and that was a terrible check mark. There we go. What I would like for you to do is I want you to try some problems. So I want you to try some equations as well as some expressions, okay? And then we'll talk about them tomorrow, okay? Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.